Morning. Well, it's morning for me. It should be 3 o'clock for you. This is my homework. I'm going to unveil it as we go through. And I just wanted to hopefully make sure that you tried some of these on your own. And just check your answers with mine. And then if you have any questions on them, I will do a Google Meet at 4 o'clock. But this was Pythagorean identities, which of course, this was the note sheet from yesterday. There's your original Pythagorean identity. And then from there, you were able to produce two more. The tangent and secant, cotangent and cosecant. Now, if you look at this first one, they told you cosine, sine was 5/13. It had a cosine. Looking for cosine gave you the sine, so that's why I used this one. 5/13 squared is 25 over 169. You just did the math, and yay, these are all perfect squares. So my cosine theta is 12/13. Because this is 90 degrees, remember pi radians is 180 degrees. 2 pi is your circumference, 2 pi r, that's 360. Pi is 180, this is pi over 2. So 90 to 180 is quadrant 2 where cosine is negative. Now number 2, use the same thing. There's your cosine, there's your sine. They don't want sine, but we're looking for tangent. So I just said, hey, this is what I have, cosine plus sine. There's other ways to do this. Now, you can if you want, and I'll show you that later. I did it on the back. But here's my cosine squared plus sine squared. There's my cosine. When you square this, you just get rid of the root sign. Here's my sine squared, and this is my sine. They didn't ask me to find this. This is not a final answer, so I can leave it this way. I can leave it as 1 over root 2. And then they asked me for tangent. Well, tangent is sine over cosine. So that's sine divided by cosine. They're both exactly the same. We are now in quadrant 3. That's 180 to 270. So in quadrant 3, sine and cosine are both negative, which is why tangent is positive. So I get tangent when you divide, 2 divided by 2, anything divided by itself is 1. Now that's one way you can do it, or if you know, see, a lot of people don't know these other identities. But if you know 1 plus tangent equals secant, you can use that one. I'm just flipping it over. 1 plus tangent theta, square theta equals secant. I'm looking for the tangent, so I subtract that 1 over. They told me cosine was 1 over root 2. So if cosine theta is negative 1 over root 2, and I reciprocate that, I just get a root 2. That's secant. I don't need to put the negative sign in because I'm going to square it and it's going to be positive, and I get my 1 that way. So you can do it either way you want. It's up to you. If you don't remember this function, that identity, you can always use cosine and sine. And then the last one is the same thing. Sine is 1/3. You're looking for cosine. Square the numerator, square the denominator. Subtract that 1/9 over, square root. Now, it just said find sine and cosine, so this is probably a good answer. If they say simplest radical form, you may want to reduce that square root of 8. And that's part 1 of my answer. I am in quadrant 1, between 0 and 90 degrees. Hooray, that means everything is positive. I come over here, tangent equals sine. Sine is 1/3 divided by cosine. You can put either one of these in for cosine. Reciprocate when you divide fractions. You always multiply by the reciprocal. The 3's divide out, and you get 1 over 2 root 2. Rationalize that because this is a final answer. And that's tangent theta equals root 2 over 4. There's your root 2. This is a 2. This is a 2. 2 times 2 is 4. This fraction, this irrational number, is this decimal. Just keep that in mind for a second. Now, as I turned it over, they gave me the sign. So I'm looking for tangent. I found the cosine. Here's my cosine, remember, root 8 over 3. Root 8 over 3, keep that in your head. That is, secant is 1 over cosine. And you'll see I erased this because at first I just threw the cosine in and I forgot to reciprocate it. But it told me my answer was wrong down here because I got a negative and I can't take the square root of a negative number. So I'm like, So the cosine was root 8 over 3. This is 3 over root 8. Square it. Square the 3, remove the root sign on the 8, subtract, and I have 1 over root 8. 1 over root 8 when I put in my calculator is that same long, ugly decimal that I got here. So sometimes I do it twice just for fun to make sure that my answer is right so I can check it. Number 4, and that's the sort of the end of the new material. I guess there's one more on the back, but the back is mostly SOHCAHTOA. Remember coterminal angles? 425 degrees and 65 degrees are going to be in the exact same spot. They're going to be in the first quadrant. 65, if you draw a little X and Y, 65 is going to be here. If you go around 360 plus 65, you're going to be in the same spot. And that's what coterminal means. Coterminal means add or subtract 360, or maybe 2 360s, or 3 360s. I'm looking for page 2. Here it is. Page 2, number 5, piece of cake. You are in quadrant 1 because 0.6 and 0.8 are both positive. This is the unit circle, so your radius is 1, and cosine is x, sine is y. So you just pull those out. If you line up x and y, you line up cosine and sine, they will line up. So there's your cosine, there's your sine. You can divide those, 0.6 or 0.8 sine divided by cosine will give you tangent, or tangent is also y over x. Same thing. Here is number 6, the terminal side of an angle passes through the point -3, 4. And they gave you a little hint. -3, 4 is in the second quadrant. So I just drew a little triangle. Standard form means the theta has to be, the vertex of theta has to be at the origin. The terminating side is where the angle stops. And then you just draw that down. All triangles on a on the unit circle always are drawn that your terminating side goes up, and it's always drawn down to the x-axis. If it's in the first quadrant, it's over here. Third quadrant, you draw that line up. Fourth quadrant, the terminating side goes all the way over here, terminates, and then goes up. Cosine or x is -3. Sine or y is 4, but in this case, because these numbers are so big, this isn't the unit circle. We've now grown up. The unit circle is when you're little. It has a tiny radius of 1. You stay in your old backyard. You don't go out into the big, bold world because you're too little. Now we're being trigonometrically an adult, and we go out in the big, bad world. And the big, bad world doesn't always have a radius of 1. So you do the Pythagorean theorem, x squared plus y squared equals r squared, and you get that radius. And then it's all SOHCAHTOA. Sine is opposite over hypotenuse. Cosecant is the reciprocal. So once you find the sine, you reciprocate it for the cosecant. Remember, reciprocal functions never start with the same letter. One has a sine, one has a cosine. Cosine is adjacent over hypotenuse, and it's reciprocal. And then tangent, you can try to divide the sine and the cosine, or tangent is opposite over adjacent. And then you reciprocate that. If you are not in the first quadrant and you find all 6 functions, 4 will be negative. and only 2 will be positive. The 2 in the second quadrant will be sine and its reciprocal. In the third quadrant, it will be tangent and its reciprocal. And in the fourth, it will be cosine and its reciprocal. Now on number 7, please pay close attention to the term exact value. You cannot just plug this in your calculator and write down some decimal it gives you and round to whatever you feel like. These are reference angles that we know the exact value of. Now sine of 90, I put 90 degrees up here. This point, if I'm on the unit circle, is 0, 1. There's your cosine, there's your sine. So when you put sine 90 in your calculator, that's why it gives you 1 if you're in degrees. Cosine 45, the exact value is root 2 over 2. You can't put down that decimal. I think it's 0.7, whatever. Add those together, get a common denominator, there I am. B, piece of cake. You can go directly to 1 because cosine squared theta plus sine squared theta is the Pythagorean identity. It always equals 1. 60, cosine 60 is a nice angle. If you put that in your calculator, it's 1/2, no muss, no fuss. Sine 60 is 0.866, some big, long, irrational number, which is root 3 over 2. Square them, there's your 1. This is a little application problem. How many radians does the minute hand of a clock rotate over 20 minutes? That's 20 minutes out of 60 minutes in an hour. We convert that first to degrees. Degrees, same circle, 60 minutes, 360 degrees. So a third of an hour is 20 minutes. A third of a rotation is 120 degrees. And then to go from degrees to radians, you always multiply by pi over 180 because 180 degrees is pi radians. The circumference of a circle is 2 pi. Half the circumference of that is pi. Half of the degrees around the circle is 180. Reduce these. You can put 120 divided by 180 in your calculator, math bracket, you'll get the 2/3. And then finally, number 9, here is your right triangle trig. Here's your tree. We always assume trees are vertical. Here's your shadow, horizontal. Angle of elevation is always at the ground looking up. That's the sun. You can't quite see it. Because I have the opposite and the adjacent sides, I'm using tangent. Tangent is opposite over adjacent. Second tangent, you always use that second tangent so that the calculator knows you're looking for an angle and not like a value that's up here. Second tangent, 28 over 32, gives you this angle. You can see that it's got to be, it's in a right triangle, so it has to be acute. We want it to the nearest minute. So once you have the angle in, you go to your calculator and right above apps is angle, and you just hit second angle, and in there someplace under, under second angle, you'll see that DMS. You can if this is already in, just hit second angle DMS, and it'll convert it to 61 degrees, 2 minutes, 41 seconds. And those 41 seconds rounds that up to 3 minutes. Okay, there's the homework. It should be, if you watch this at 3, it should now be 3:15-ish. Join my meet if you have any questions. Take care, and I hope I made Pythagorean identities somewhat understandable.